Hello students, I hope you are good, well and fine. Today we'll be continuing our discussion on surface area and volume on its exercise. Okay, so let's discuss the exercise more so you can understand the concept and the formulas, that how we are going to use every formula and how the questions will frame in future. So let's see the first question. So our first question says that how many balls of each of radius 1 centimeter can be made from a solid sphere of lead of radius 8 centimeter. So I have a bigger sphere. So I have a bigger ball, say bigger ball. Sphere means solid ball. Okay, bigger solid ball of radius. What the radius is 8 centimeters, and I have a small ball of a solid ball of radius 1 centimeter. So I need to find out that how much of blue balls can be made out of this big red ball. Okay, so this is the very clear that the question asking me to find out the volume for this and the volume for this, and then divide the volume of the bigger solid ball to the volume of the smaller solid ball, so that we can find out how many small blue balls can be made out from this red big sphere of radius 8 centimeters. So let's see. So volume for a sphere, if you recall, is 4 by 3 pi radius cube. Okay, so pi radius cube. So the volume for the red spherical ball of radius 8 is, just apply 8 here and we get our volume in centimeter cube. Now for smaller piece, I'll just use the radius as 1 centimeter. So the volume for small sphere or the blue ball is 4 by 3 pi r cube. R is 1, so 1 cube is 1. So this is 4 pi by 3, and this is my 4 pi 8 cube, 8 cube. So 8, just 8 cube. I'm writing just 8 cube, not evaluating further because things will get cancelled, I think. So let's move to next. Now just divide to find out the number of balls. So just volume of big sphere, volume of a big sphere divided by volume of small sphere. Okay, so I know this volume, this is my this, and I know this volume, this is my 4 pi by 3, just this. So doing this will be my n, and what is my n? N is the number of smaller balls that can be made. Okay, so n is the number of smaller balls that can be made. So n is equals to the volume for the big divided by volume for the small, which is this, and this whole thing, this term will get cancelled. So we are left with just 8 cube, and 8 cube is 8 times 8 times 8, which is, if you calculate this is 84 or 64, and this will get 512, and this is my answer. So the required number of ball is 512. So we can make 512 balls out of the big sphere of radius 8. Okay, I hope this is clear to you. Now let's move to next. Moving to next, this problem says that by melting a solid cylindrical metal, so first of all visualize, so we have a cylindrical metal like this form. Okay, a few conical materials are to be made. That means this is transformed transformed into cones. Okay, so something like this. Okay, something like this. I hope this is clear. Okay. Okay. Now, what if 3 times the radius of the cone? So, cone radius, let's say cone radius is this, my cone radius. Cone radius 3 times the cone radius is equals to twice the radius of the cylinder. So, twice the radius of cylinder. I hope this statement is clear, and this must be and the ratio of the height of the cylinder. So ratio of height of the cylinder. So height of the cylinder to height of the cone, height of the cone is equals to 4:3, or just write it as like this, 4/3. So we are given with two piece of information. First one is this, second one is this. So we have to find the number of cones. So we are now the task is to find how much of the the how much the number is that the if we transform this cylinder into cones. So what is the number that the cone be made out from this? So the number of cones which can be made from this cylinder. Okay, so what we are so what we have to find out, it is the question of volume. Okay, because we have a solid cylindrical metal, and we have to make a solid cylindrical solid conical materials. Okay, I hope this question is very clear to you, and the information given to us is also clear to you. Let's see how we will approach. So now we are taking capital R as the radius of the cylinder and capital H as the height of the cylinder. And for cone, the radius is small r and height is small h. And we are given the radius of the cone, 3 times the radius of the cone is equals to 2 times the radius of the cylinder. So by equation we represent like this, and for ratio it must be like uh, so this is like this. So H ratio, capital H ratio, small h is equals to 4:3. I hope all is clear. Now using formula for volume. If you recall the formula for volume, volume of cylinder, you all know pi r square h, and volume for cone, volume of cone is equals to pi r square h divided by 3. It is just the same of this, but divided by 3. I hope this is also clear. Now I have this piece of information. Now to find out the n, and n we are taking as the required number of cones which can be made from the material of cylinder. So let's see. So just using the volume formula, I used like this, just dividing. So because the cones are made out of from cylinder, so cylinder volume is going to divide by the formula or for the volume of cone. So it is 4 pi this. So now just these will get cancelled, and by solving for this will give me the r by r. I can rewrite it as like this, because I know ab whole square is equals to a square by b square. Okay, now I know r by r and h by h. H by h is 4/3. I think 4 it is 4 by 3. Yes, h by h is 4 by 3. So h by h is 4 by 3. Let's move to C. So just applying all the values, I'll get this h, the r by r, and h by h I have, and this 3. Okay, this is this, just solving it. So r is this, or I can say r by small r is 3 by 2, just applying 3 by 2 here. So 3 by 2, and h by h is 4 upon 3. So this gives me h by h is 4 upon 3, which is 4 upon 3. Now just solving for this bracket, it will square each of the term, and 3 square is 9 and 2 square is 4, and then we cancel these terms. We left with only 9. So 9 is my n and is the required number of cones. Okay, so I hope this is also clear to you. Now let's see the next problem, what it says. Now the problem says the water flows at the rate of 10 meter per minute. That means water is flowing through a cylindrical pipe. So my pipe is like this. So let's say this is my pipe, and from this my water is flowing. Okay, so water and my pipe. I hope this is clear. That means water is coming from somewhere here. Okay, I hope you are getting the idea. Now what? Now the pipe, having pipe, its diameter as 5 mm, 5 millimeter is my diameter. That means this hole, this circular part over here at the one end of the cylindrical pipe, we have a diameter of 5 mm. Okay, 5 mm. Now what? Now how much time will it take to fill a conical flask? We have a conical flask like this. This is my conical flask on in which the water is pouring. Okay, so this, my water is now here. So, and this, if you see the base, that means this diameter for the conical flask is 40 centimeter, and the depth, that means this, or the height, h, is equals to 24 centimeter. First of all, see the units are different, meter, millimeter and centimeter. First of all, change it to single unit, and then solve it. Okay, so first of all, let's do it in centimeter. So millimeter, 1 mm is 1 by 10 centimeter. That means 5 mm is equals to 5 by 10 centimeter. That means half centimeter. Now radius of the pipe is the half of the diameter. That means 1 by 2 times 1 by 2 is equals to 1 by 4 centimeter. In 1 minute, if you see, in 1 minute the information is given, already given. The 1 minute, the length of the water column in the cylindrical pipe is 10 meters. That means we know 1 meter is equals to 100 centimeters, and 10 meter is equals to 1000 centimeters. So this is my length of the cylindrical pipe. Okay, now let's move to next. So for the volume, we know the formula is pi r square times h. H is my 1000, r is my 1 by 4, so r square is 1 by 4 times 1 by 4, and pi is already there. By just this is my volume of water that flows out of the pipe in just 1 minute. Now the volume of the cone, so volume of the cone is the pi r square by h by 3, and the r is the radius for the cone, and h is my height for cone. Okay, and pi is my constant, and 3 is also my constant. So using the formula and the respective values I get, because the diameter for the cone is 40 and radius is my 40 by 2, so it is 20. So r square is 20, and height is already given to me, the 24. Now this is my volume of the cone. Now just on dividing, the time needed to fill up the vessel is just divide this cone volume by the volume of the cylindrical vessel. Okay, so sorry, the cylindrical pipe, cylinder. Okay, now to get this, after solving, or after just here must be the brackets. Okay, and here. Now just by doing some manipulations, you will get your answer in minutes, which will be 51.2 minutes. Hence 51.2 minutes the vessel get filled. I hope this is all clear. Now let's move to next question. So now we will see objective problems. So let's see some of the objective problems. So first, the height of the conical tent. So we are given with a conical tent, something like this. At the center of the base is 5 meter. So the distance of any point on its circular base, okay, from the top, so from this point to any point on the circle, that means on the circumference, that means this length is given to me as 13. The area of the slant surface is equals to, so we are asking for the curved surface area. In the curved surface area for the cone is pi r l. Okay, so pi r l. Okay, now we are given with the height of a conical tent at the center is 5 meters. So the height is of 5 meter, not centimeter. It is given to me in meters. And the distance of any point on its circular base, so that any point distance from this point to any point on the circular base, that means on the circumference of the circular base, which is of my 13 meter, that means L is given to me my 13 meter. So from this information I know the relationship L square is R square plus H square. L is given to me 13, H is given to me 5. That means 13 square is 169, which is equals to the R square, plus H square is 5, 5 square is 25. Solving it will give me 69 minus 25, which is 144. That means R is my 12. So now R is my 12. Now the formula for the curved surface area for the cone is pi r l. Now plugging all the values, pi times r, which is 12 and 13, this will give me my answer. So 12 times 13 is, let's do some calculations. So 3 times 2 is 6, 3 times 1 is 1, 2, 1, which is 156. So 156 meter square is my answer. 156 meter square is my answer. So the option C, 156 pi meter square, is the correct option. Okay, let's move to next. Now a rectangular sheet of a paper 22 centimeter long and the 12 centimeter broad. So if you see a rough diagram for this, my paper sheet is 22 centimeter long and 12 meter broad, or 12 centimeter broad, and this is a rectangular shape. So this shape can be curved to form a lateral surface of a right circular cylinder in two ways. We know if I'm trying to transform this rectangular sheet into a cylinder, the cylinder will look like something this. So it is wider but not long. The cylinder will look like wider, and this is I already know this. The circumference of this base circle is my 22 centimeter, that is 2 pi r is my 22. That means r is equals to my 22 by 2 pi, which is 11 by pi, and pi I already have is 22 by 7. That means r is equals to 11 by 22 times 7, that is equals to 7 by 2. So r for this, r is equals to 7 by 2. Okay, now what? Now we have the r for this. Now volume for this cylinder is equals to pi. Pi is I'm just writing pi as pi r is 7 by 2, r square means this. So this means 49 by 4 times the height is my 12, height remains this, the 12. So this is my volume for this cylinder. So 49 by 4 times 12 pi. I hope this is all clear. Now let's the another way to form our cylinder is now we put our sheet like this. Here the sheet length is 12 centimeter and the width is now 22 centimeter. Now if you try to make a cylinder out of it, the cylinder will be now longer, not wider in comparative to the previous. So here this height remains the same, but here the radius get changed, which is we know this whole length is this. That means here the circle is there, so 2 pi r, the circumference of the circle, is equals to 12. That means we already know, that means from this r is equals to 22 by 2 pi, from this is 6 by pi, and I know pi we are using 22 by 7. That means 6 times 7 by 22, which means 21 by 11. I hope this is equal, and for this the volume is equals to pi r square, which is 21 times 21 and 11 times 11. I hope I am not doing any calculation mistakes. Okay, and now times h is my this 22. Okay, I hope this is all clear to you. So I cancelled from 3, so remains is sorry, cancel with 2, it remains is 3 and 11. So 7 times 3 is 21 and 11 is there. So yes, here is my volume, which is 21 by 11 whole square times 22 pi. I hope this is clear. So, and we are asking for the difference. So one, let me do it here. So 49 by 4 and this 4, okay, and this 4 will also do sum. So 4 times 3, so this is just 3. So now 49 times 3 pi minus this 22 pi 22 pi 21 by 11 whole square. I think this is what we needed. So now taking the values common, I am now using the pi value, taking pi common. So pi is common. Now 49 times 3 minus 22 times 21 times 21 divided by 11 times 11. I see that this 11 will cut this 2 times. So this is now 2. And here I am remaining with this. Now just solve it and you will get your answer as 10. So the option B for this case is correct. Now For this question, the percentage increase in the surface area of cube. So we know the surface area for the cube. The surface area for the cube is, let's say, if a cube having side is equals to x, then the surface area or the total surface area, which is equals to uh, is 6 times of x square. So the total surface area is 6 times of x square. Now when we need to find out the percentage increase in the surface area, if the every side is increased to 3 by 2, that means our previous side was equals to x, now the new side is 3 by 2x. I hope this is also clear. So now the new cuboid with this new side, the curved surface area, or the total surface area will be my 6 times of 3 2 by whole square. That means 6 times 3 times 3 2 times 2 x square. This means this 2 will get cancelled to this, and this will remain here. So 9 times 3 times 3 times 3 is 27, and here the 2 remains. So now see how much of the area is increased, or let's see how much of the area increased. So now 27 by 2x square minus 6x square will give me the 27 minus 12 whole multiply with x square by 2, which is 15. So 15 by 2x square. So this much of area is increased area after increment inside, after increased size. Okay, now we know this much of area is now increased. So in a percentage we are evaluating, we know the 6x square gives me the 100%. Okay, and this means if I need to find out the 15 by 2x square gives me how much of percent, how much percentage. So just put just first of all multiply with divide by 6 each side, I'll get this, and multiply with 15 by 2, 15 by 2 here, I will get 15 times 100 is 1500 divided by 12, and by just evaluating it, I'll get my answer, which is 3 times is 4, 3 times 5 is this. Now 500 by 4 is, I think, 125. Let me do it. So 1 4 1 is 2 2, so 2 is 8, now 2 is 5. So 125 is my answer. So 125, this much of percentage is increased. I hope this is all clear. So let's see the final answer. Yes, D is my final answer, or the correct option. So I hope you understood all the concepts, all the approaches I did. So let's meet again. So thank you for your attention. Thank you.